Hi everyone, my name is Brittany, and I decided to do my presentation on trigonometric ratios of a right triangle. So as you can see, I have listed all of the trigonometric ratios, all six. The first three, sine, cosine, and tangent, and then there are reciprocals, cosecant, secant, and cotangent. You'll notice that sine, cosine, and tangent with their reciprocals are the complete opposite. So the sine, instead of being opposite over hypotenuse, is hypotenuse over opposite. And I really like having a visual so I can see kind of how those all align with each other. So to jump into our first problem, we have a right triangle and we are given the hypotenuse. And the first angle we're going to be finding is B. So we're going to call 8 our adjacent. So I like to have, in any problem that I do, I like to have a shorthand of the solution. So sine opposite over hypotenuse and so on. So what do we know about this specific problem? We know that we have our adjacent is 8, our hypotenuse is 10, and we know it's a right triangle. What do we need to know? We need to know the opposite, and we need to find the values for angle B and angle A. Now, to find the value of A, we can use Pythagorean theorem because we have two of the sides already. So we know that A squared plus B squared equals C squared. Therefore, A squared plus 8 squared is going to equal 10 squared. If we switch that around and move the 8 squared onto the other side, subtract it from both sides, then we have A squared equals 100 minus 64, which leaves us with A squared equals 36. And then A will equal the square root of 36 or 6. So now that we have all of our sides, we can plug in all of those numbers for all of our trigonometric ratios. So for this slide, we have all of the trigonometric ratios for angle B. And we could use any one of these and it should come to the same conclusion. On the next slide, we have all the trigonometric ratios for angle A. For the sake of ease, I went with sine for both of them. So we're going to find the values of B and A. So sine B is equal to 6 divided by 10. But to find B by itself, we have to move sine to the other side of the equation. So instead of sine, it's going to be the inverse of sine or arc sine of 6 divided by 10. And then that comes to B equaling 36.87 degrees. Now, if we do the same thing for sine of A, instead of 6 over 10, our opposite is now going to change. So it's going to be 8. So our opposite over hypotenuse is 8 over 10. And then we are going to move our sine onto the other side of the equation again. So instead of sine, it will be the inverse of sine or arc sine of 8 over 10. And that will come to 53.13. Now, something really important with every math problem is to check our work. So we know that A degrees plus B degrees should equal 90 degrees. Now, the values that we got for those for A and B are 53.13 degrees plus 36.87 degrees, and that does equal 90 degrees. So our check worked. Now we have all of the values that we were missing, and this triangle is solved. For our second problem, we are going to find the trigonometric ratios again, but we are going to have two different values. Instead of two sides, this time we're going to have the hypotenuse and an angle. So again, I like to have these listed. What do we know about this problem? We know that angle B is 35 degrees. We know that the hypotenuse is 12, and we know that it's a right triangle. What do we need to know? We need to know angle A, we need to know the opposite, and we need to know the adjacent. Now, the first angle that we're going to solve for is A. So we know that A plus 35 should be 90. We do have one of the angles, so this is an easy one to solve first. 90, and if we move the 35 to the other side, so subtract 35 from both sides, then we have 90 minus 35 equals A. Therefore, A will equal 55 degrees. Now that helps us a little bit. So I just recorded what we know, and we know the hypotenuse. So I put the hypotenuse, and we're going to solve for 35 degrees. We're going to solve with 35 degrees because that's the angle we were given. So we have sine of 35 equals A over 12. Now this is actually really easy. If we just move the 12, so if we divide or if we multiply both sides by 12, then we can easily get A by itself. So sine of 35 times 12 is A, and then sine of 35 comes to 0.57, and A equals 6.88. Now the cosine of 35 will help us to find B, which is another easy way to do that, so we don't have to switch angles, although you could do sine of 55 and still have B over 12 if you wanted to keep the sign. So we know that if we divide both sides or multiply both sides by 12, then we will have B by itself, in which case B will equal 12 times the cosine of 35. And then the cosine of 35 comes out to be 0.82, and B will equal 9.83. Now again, we want to check our answer. So we know that we can use Pythagorean theorem for that. A squared plus B squared equals C squared. And then we have our A was 6.88 squared plus our B 9.83 squared is going to equal 12 squared. So then those values come to 47.33 plus 96.63, which is going to equal approximately 144. I think it was 143.98 or something. It was really, really close. All right, so we solved for all the missing values and those are all recorded here, and we checked our work. We need to know all the 6 trigonometric ratios to solve any of these problems. Second, we need to acknowledge what the problem gives us. Then we need to choose a ratio that will help us to find the values that we're missing. Finally, we want to check our work and then celebrate because we figured it out.